Now let's do a comparative chart about the inoculum, where we have the inoculum here we have 1000, and we are going to see how many viral particles we have 1 hour, 2 hours, 3 hours, 10 hours and 20 hours after, in this case, the viral particle, or in this case, the 1000 viral particle infect the human cells. So we said that the replication period is 1 hour. So if this one viral particle infects one cell, it's going to get replicated in 1 hour. So 1 hour later we are going to have 2 viral particles. In this case we have 1000, so if we have one viral particle gets replicated in 1 hour, and in that hour we will have 2 new viral particles from one previous viral particle, then we have that times 1000. So we will have 2000 viral particles. Here we have 2 hours later, so we have 4 viral particles. The formula, we saw it in the previous video, was 2 to the number of hours. So here 2 to the 4, 4 viral particles, 2 to the 2, 4 viral particles. Here the same, both multiplied by 1000, so 4000 viral particles. Is the same, we think it the same way as this, just multiply by 1000, because we began with 1000 viral particles. Here 2 to the 3 is 8, here would be 8000. Here 2 to the 10 is 1024, which is approximately 1000. And here, so 1000 times 1000 is 1 million. 1 million. Here 2 to the 20, 2 to the 20 is 1000 times 1000. So I have not enough space. 1, 2, 3, 4, 5, 6. Here, so 1 million. And here we have 2 to the 20 times 1000. So if this is 1 million times 1000, it will be a billion. A billion. So here, when we have 1 viral particles, it takes like 20 hours in order to have 1 million particles. 1 million particles. And here it takes 10 hours to have 1 million particles. Here it takes 8 hours, in 3 hours to have 8000 viral particles, and here in 3 hours we have just 8 viral particles. So if we have this case, it would be very easy to tame this infection by immunological response. If we expose one person to just 1 viral particle, we have enough time to get the immunological response very, very efficient. Because just 1 particle, then in 1 hour 2 particles, in 2 hours 4 particles, is very straightforward. Here we have one viral particles de súbito. So in the first, let's say the first exposure, we have 1000 viral particles introduced in the human being. So the immunological response don't need to just tame 1 viral particle at the beginning, but needs to tame or attack 1000 viral particles at the beginning. And if we continue this, in 2 hours we need to tame or attack 2000 viral particles. And this is going to grow up very, very fast, because this is an exponential equation. So here we are going to overwhelm the immunological response. In 10 hours we have 1 million viral particles, and this outgrows or overwhelms the immunological response. We cannot attack all this very efficient with the immunological response. It takes time. But here, 1000 particles in 10 hours, we can attack them very efficient comparatively. So here we have like exposed the immune system to particles, viral particles, but let's say like step by step. And here is the subito, we have 1000 viral particles, and so this, when it replicates, it grows very, very fast. So here in 10 hours we have 1 million, and we cannot, by the immunological response, it is not going to be very efficient to attack 1 million particles because it takes time. It's not the same to get infected with one viral particle and that one viral particle gets replicated and we attacked by the immune response, that having 1000 viral particles de subito, then continue replication of the 1000 viral particles, and the immunological response, it's not the same because the immunological response is overwhelmed by this exponential growth. So we say we have two exponential growth that are competing. One is exponential growth of the viral replication, and the other is the exponential growth of the immunological response. The immunological response also going to be an exponential function, but it takes time. In this case, the immunological response it is not overwhelmed and we can attack very efficient, but in this case don't. So here the exponential growth of the viral particles overwhelm the exponential growth of the immunological response. Now let's continue reading. So we could say, if the exponential growth of the immunological response outgrows the exponential growth of the virus replication, we have not just reached immunization, but we might have the solution to the pandemic and to many that will follow. If some way we could make that the immunological response, that the exponential growth of the immunological response don't be overwhelmed by the exponential growth or the exponential growth of the viral replication, that's immunity. We have reached immunity, because if this outgrows this, we are going to attack very efficient, which is not the case in this pandemic right now. This is not happening because millions and millions of viral particles infect one person de subito. So we need to do this. We need to make sure that the immunological response be greater than the exponential growth of the virus, of the viral replication. So we could say it's a matter of competence between two exponential functions. On one hand, the exponential reproduction of the virus, and on the other hand, the exponential production of the antibodies and T cells. The aim is to diminish the amount of the inoculum to the minimum capable of infecting the minimum susceptible cell population in a susceptible person. So if we could make that instead of a people or person getting infected with 1,000 viral particles, let's see what if the person gets infected with the minimum amount of viral particles which we need to have to get infection. I'm not saying just one viral particle, I'm just saying the amount of viral particles that we need to get infected, or that the person will get infected, but the minimum. Let's say if the person needs 20 viral particles in order to get infected, in order to manifest the disease, so let's see how we could make that instead of getting exposed to 1,000 viral particles, just be 20 viral particles, the minimum amount that we need to make the disease in one person. So let's continue. It is the concept of the use of mask and contagion are intuitively described as a discrete phenomenon, even more so Boolean, when in reality it is a continuous one, at least concerning the amount of inoculum, not two patients receiving the same amount of inoculum. So everything, it seems like discrete, and it also seems not just discrete, but Boolean. Discrete is, well, not continuous. We could say that some people use mask, others don't, others yes, others don't, but that is Boolean, and not only things are Boolean in the